Hello, everybody. Thank you very much for the opportunity to be on this scene. Uh, Today, I would like to introduce some one of project which we do inside our company together with one integrators, local integrators in our country, and this project I think will be inspired you for new ideas and warm welcome to additional questions and discussions after presentation. A little bit about me. I have around 10 years experience in CAD/CAM when I start with ENCY 10 years ago. We have done around 15 different robotic application in Slovenia and Croatia, and also in Bosnia, because we have such this market is very connected inside Adriatic region, I could say, Adriatic Balkan region, and usual customers comes from Bosnia to order some robotic cells in Slovenia, and so and so. And today I will show you some project with 3D printing, but not usual 3D printing, which you already know very well. It is usual plastic materials, but it is concrete printing. Maybe you heard about it, or maybe you also seen some project with housing 3D printing. But today I will introduce a little bit different approach to this process. We speak about two component 3D printing from concrete. Later I will explain this technology more detailed. Okay. At the beginning, let's speak a little bit about differences to traditional methods using of concrete. You can see, for example, like on this picture, in traditional methods, you need some mold where you put concrete, wait a little bit when it is will be dry, and then destroy this mold to extract your concrete part. This process have some limitations, and I also clearly can see on the picture one model which impossible to produce with traditional methods with some weaving patterns. And 3D printing with concrete give us some advantages. We can use less material. We can reach some forms which it's not impossible with traditional methods. Also faster, maybe less people involved. Also picture clearly see how many people needs to do traditional method. You can see 4 people on the picture, and only one robot from the right side. But it's true because to produce mold, you need some specialist for molding. Then you need some specialist who made the mixture, and specialist who pull this concrete mixture inside the mold. Okay, some comparison between methods. Labor costs in traditional construction a little bit higher than in 3D printing, but it's depend from difficulty, I could say. Time to build, it could be days with 3D printing. Flexibility in design, because we can print practically any form. Less waste of material. And for printing we need just robot cells with appropriate pump, and so we can start. and also we have good scalability, because we can reproduce it many times with the same process, robot speeds, and so on, and we can produce many pieces of the same parts. Here is some examples what we can do with 3D printing. How I said before, it is buildings. Maybe you heard about Starbucks coffee shop in the America, in the US. It was printed, and it was printed with robot, how I remember. And also one store shop of Walmart also was printed in US, but I think they use not they use robot, maybe use portal machine. I don't remember which is project was done with robot. But today we speak more about smaller construction. It is street furniture, like this bench. This bench was produced by ENCY and in our with my customer. These sculptures, and for just examples, is some shelter or bus station, small concrete construction, as example of parts. Okay, now I would like to go deeply to my project. What we do. I met some man. It is a doctor of chemistry. He know everything about concrete. He can do good mixtures, and he already use robots for some serial production of small concrete parts. But it was traditional method. When he think about that he has a robot and he can start 3D printing because it is trending, and it is very interesting for him. And main goal was for him to introduce new mixture, which give possibility to make 3D printing with two components. I will explain how it looks like. And we started together with one integrator inside Slovenia called Snopromat. We do this cell, of course, some electric cabinet, Fanok robot, a little bit lighter Fanok robot, but because he already had this robot. And compared to just normal one component 3D concrete printing, we have here important thing. It is printing head. Printing head needs to mix concrete with accelerator. Accelerator needs to makes concrete dry faster. In this case, we can print with negative angles. We can print very high construction, and don't afraid that it broken before we finished. And to mix these components together, usual components mixed right on the nozzles. Yeah, and in this case, nozzle a little bit bigger than usual when you have just tube at the end. So fourth important component, it is concrete mixer and pump, which mix concrete with some additives and pump it to the printing head. What we have done? What milestones we had? We start testing different mixtures, and at the beginning it was not great, and material was too granulated or too dry, and something else. But we know that it is exactly what we need. We need test different material, different mixtures, and finally, from step by step, this doctor Luca find great um, great recipe. Yes, like on cooking components on your kitchen. Yeah, he also have found a great recipe for that, and finally start produce this mixture to sell it worldwide. Also, he start to do some small orders and make some small batches for different external orders. And we have figured out that small robots have some limitation, and would like to upgrade it. And now we are on this way to upgrade this robotic cell. Okay, it was a first project. I make some short overview, some interesting projects, because we have a lot of prints of different parts, different furnitures, and I will make some look up for different interesting projects where we faced with some problem maybe, and how we um, fixed this problem. It was our first part. It is for plants, garden planter, and the problem was that at the bottom you can see we have more waves, but at the on the top of the planter we have more straight toolpaths, more straight forms. And if you work with robot before, you know that robot, if we have a lot of changes of direction, goes slowly, and if we have straight way, it goes faster. And we have a problem that thickness of material was bigger at bottom and less at the top. And for particular case, I made some changes for post processor to adjust speed from top to bottom, and we start with higher printing speed and then decrease speed of robot when we comes to the top part of this printer. In this case, we have able to print more or less consistent thickness of layers. I will show you some video, and you can see the first previous picture. It shows some first case when we only start, and everything was not so good, and you can see when we found right solution how it looks like much better. Next project, which was also some special, we try to print the sphere. Yeah, it is sphere hollow inside, nothing inside, and it was printed from zero. Here we faced with some small issues. First, I faced some with issues with trajectory creates, because we have changing from vertical to totally horizontal toolpaths, and we should find some good way to generate consistent toolpaths for all part of sphere. And we able to do it with adaptive step, but not ideally. Maybe after update ENCY 2.0 it will be much better, because Andrei said that we have updates in this area, and I think we can do much better. But this is also fascinating. You can see final result on the video. Sorry, it is how I try to create trajectory, and first approach was not so good, because I did not receive tool pass in the center of my sphere, but finally we do everything as much ideal as possible. And you can see the process. Of course, sphere have a little bit sliced at the bottom to be able of staying, and it's quite stiff. You will see when it will dry. You will see how it looks like. Next issues what we faced with especially concrete printing, it is weaving patterns. Weaving patterns, usual designers would like to use, would like to show that 3D printing's better than traditional methods, and this weaving pattern you cannot receive with traditional methods, but it looks really fascinating, and designers would like to use it. But the problem is if we use, for example, 5D surfacing operation for additive manufacturing, 5D additive operation, they use surfaces. And if we try to generate such trajectory from surfaces, we receive a bad result. And we tried, result was not so good. Layer density mismatch between views, interference line structure was not so good. And I make decision to do the same, but with normal 6D contouring operation, which is not a part of additive package, but we can use this operation for additive manufacturing, and ask designer to generate for me just lines without any surfaces. And we have we have successful case in here, and we was able to do perfect pattern. Additionally, I also use possibility of robot to smooth tool path, and this possibility give me ability make weaving with really smooth corners, and I generate lines only with linear interpolation. In this case, a robot makes this smoothing between sharp edges. In same way, I will do also with this project. It was project for our city Novogoritsa, where this years have a name of European Capital of Culture together with Old Goritsa or just Goritsa from Italian side, and it was some artistic objects installed on square, and we have printed it. It is also challenging project because you can see that pattern again changed on this. I know it is benches, something like benches. It has straight pattern, weaving pattern, and we again use structure with curves. Yeah, and here is I was a little bit I would say nervous, yeah, when I created, because designer generates these levels level by level, and I have 200 layers, and for 6D operation I need to check every layer, add it to job assignment. For every layer, change the start point, because I would like to be start point inside of my structure to be invisible steps. And it was it takes some time, yeah. And I hope developers will introduce some simplified operation for, especially for 3D printing, based on curves, not only on surfaces. Yeah, small video shows how we print these objects. Okay, now I would like to introduce how what I do for this project, what I implement, what I add to the ENCY from my side to be able to do such a great job. I have added some additional parameters, so-called customs operations, scripts operation. And I do it because, how I said before, I work with chemist, doctor of chemistry. He is not robotic, also not chem engineer or CAD engineer, and for him it's hard to manage a lot of parameters. And I would like to give him all parameters in one tab, and I integrate all parameters in one tab of settings of operation, and where he can change the layer height, layer thickness, and some additional parameters for printing. And in result, it is faster because I have prepared parameters for some average print, and he can quickly change just 2 or 3 parameters and start generate toolpaths. Of course, we change post-processor. We use post-processor for Fanuc robot, and I changed the standard post-processor for Fanuc robots, add using of splines, because we try to found the best solution how robot can move smoother. I will explain later what I talk about. And we use splines also in this project. Of course, I generate in this way that he just click run button, copy file, paste it in his robotic cells, and he have HMI interface, and just put number of program and start robot. He don't care about anything. Usual it works without any problem. He need only one dry run to see if it is works good and movement is smoother, and he start job very fast. We can do in one day 2, 3 different designs together with programming. What next challenge we had? It is point density. If you work with robot, you know, if you have a lot of points together, close together, robots start to think a little bit more than you need and decrease the speed of movement in these areas. Especially worst case when you have 2 points at the same point in the same place, and it is negatively influenced to the robot speed, and especially with concrete, we cannot stop pump. You have seen on the picture of whole cell, we have the tube with 3 or 5 meters long. Pump works constantly, and printing speeds should be pretty high. And we cannot change the speed of pump, or we can, but when it comes to the nozzle, it takes a time. We are not no more in the area where we would like to do it. And point density and constant speed, it is important. But in ENCY, hopefully, we have different type of interpolation, and when we play with interpolation tolerances, we can define the most ideal tools distribution. And it is depends from project, depends of lines, surfaces. But when you play a little bit, 5 minutes with different values, usually we can do instead this a lot of points here. In this case, robot cannot able to reach the target speed. Then we can try to increase tolerance, less points, but not still acceptable. And then going to the, for example, spatial arcs interpolation gives us the best result. And main issue, which is not totally fixed at this moment, it is speeds drop at the corners. It is our core challenge which we faced up because robot breaks at the corners to able make this movement. And when it breaks, how I said before, thickness of layer becomes bigger. And you can see here how here inconsistent layer we have. Because the robot cannot move faster on the some curvatures or sharp corners and so on. And we have bad result. What we did do to make a result better. First, we test with different robots, with different robot size and different robot producers. We try on Fanuc, KUKA, ABB, and in principle, we find that robot in the middle range of payload have a good result. He is still fast, and at the same time, it have enough payload to hold this heavy two components head. And we make a test, and usual every producer have such problems, and we have usual some limitation at the speed. For example, we cannot print this one at 300 millimeters per second because it is too fast for robots, and anyway such pattern will be speed will be less, it goes down, and we need made some dry run to see and notice what limit of speed we have in such cases, and then using this limit of speed adjust pump speed, because it is important to harmonize speed of robot and speed of pump. Also, we try to use different approach to tool path generation. I mean, linear interpolation, circular interpolation, also spline interpolation. And in some cases, spline works very well. In other cases, better using line plus smoothing, because what we noticed, the usual circular interpolation by robot also have limitation. It means he breaks down speed more than, for example, if we use natural smoothing from robot and use two lines. And current strategy to achieve a constant speed, first make a dry run or make a simulation in robotic software, which if we have it, and log actual minimal maximal speeds and adjust speeds after that for real printing, and then pick optimal robot type plus interpolation for each cases. What are next plans? It is bigger robot which can do bigger objects and also have better speed control. We compare it, for example, with 50 kilos payload, old robot, and this bigger robot moves much better, much smoother. We also would like to add the rotation table to make to be able print again bigger objects. And also big our opportunity will be to implement not only 3D printing but hybrid process with concrete. It means after printing we can mill this or grind the part. It means we receive some more interesting forms, more interesting parts, and this technology is really in a very early stage. Practically nobody tried yet. Just some cases exist. So, and ENCY, I think the only one software which can do it. It means hybrid operation, 3D printing, and then milling or grinding existing parts. Simulation, everything in one screen, in one project, we can all simulate. And it will be a really fascinating project to show it everywhere. I hope we will finish it in the end, until end of this year. So, if you have any question,